So positive half cycle, value is 0. Nothing. But the capacitor has charged with plus on the left, minus on the right. This also, by the way, will help you in your lab pre-lab for the next lab. So capacitor charges plus on the left, minus on the right, because the current flows from the power supply. In the negative half cycle, the exact opposite happens. And this is where I find this model particularly useful. Think of this as a battery. So you get plus minus, and now you have a capacitor plus minus. Negative half cycle, cathode is connected to positive end, so it's off. What is V out? So observe the circuit, think about it. What do you think is V out? Absolutely. VC and the power supply are now in series, so it adds on to your point earlier, and you get V in by 2 plus VC. Effectively, you get V in. But it's the negative cycle. Everything is reversed, so it's minus V in. And so you get the full length. The full swing of the voltage, but in the negative direction. It clamps it. It's modifying, it's shaping the waveform, and it is clamping it at a certain level. Okay. And this is just one kind of clamper circuit. There are multiple kinds of clamper circuits. You could flip the diodes, you could flip the voltage sources in there. You can, even in the clipper circuit, you can flip the voltage, the battery that you're applying, the voltage source. Also, you can flip the direction of the diodes. You could have multiple diodes in the same circuit, which is again there in the lab. But when you get down to analyze this, the approach doesn't change. The approach remains exactly the same. Okay. So use the ideal diode model and you'll be able to analyze any circuit you want. Yes. So good question. Will the capacitor try to charge in the opposite direction? Yes, instantaneously. It won't discharge instantaneously. So it'll try to discharge to the resistor. So even though the direction is reversed, the capacitor, we choose the values of the capacitors and the resistor large enough that it does not discharge a lot. So it holds its value, and you'd be able to see by the time it even loses a little bit of the value, the next cycle will arrive. That would again behaves like a short circuit. Capacitor charges all the way again. Yeah, that's a good point. All right, so we are out of time. We'll end class here today, and we'll see you all on Wednesday.